class, this is lesson 5.4, medians and altitudes. We will learn to identify properties of medians and altitudes of a triangle. Do a quick review. Our three diameters of a circle concurrent? Yes. In the center. Our two diagonals of a rectangle concurrent? Yes. Is point C at the right of point of concurrency? Yes. True or false? So here's our theorem we're going to use, concurrency of medians theorem. Medians of a triangle are concurrent at a point, the centroid of the triangle, that is 2/3 the distance from each vertex to the midpoint of the opposite side. For any triangle, the centroid is always inside the triangle. So this line right here would be 2/3 of this line. So DC is 2/3 of J. BC is 2/3 of BG. And FC is 2/3 of FH. So we can use that to find the length of the median. So if we are given that SP is 16, so that's 16, well, that's 2/3 of the whole segment SM. And we can write that like this: SP is equal to 2/3 times SM. We know SP is given as 16 if we substitute that in. Now if we multiply both sides by reciprocal 3/2, we get 3 times 16 is 48 divided by 2 is equal to SM. So SM is 24. All right, the altitude of a triangle is the perpendicular segment from the vertex of a triangle to the line containing the opposite side. The altitude can be inside or outside the triangle. It's shown here. AE, A is AC and median. The line AC, since it meets at the midpoint of the side opposite, we can tell that by those congruent marks there. AC is a median. AE, since it is a perpendicular line that goes from the base of the triangle to the opposite vertex, that is an altitude. concurrency of altitudes theorem, a line that contains altitudes of a triangle are concurrent. The point of concurrency is the orthocenter of the triangle. The orthocenter of a triangle can be inside, on, or outside the triangle. So we're going to use an example of each of these to see whether when it will be on the triangle, when it will be inside the triangle, and when it will be outside the triangle. So let's make an acute triangle. Draw one like this using the x-axis as the base. An obtuse triangle. And a right triangle. All right, if I draw the altitudes in here, and we know they're all going to be concurrent at a certain point. So if I just draw two of the altitudes, I can find the orthocenter. So this first one, we can see this would have an altitude on the altitudes in red. Right here is an altitude because that's a line that's perpendicular to the base and touches the vertex there. And then to find another altitude, I'll do an altitude from right here, this point. Now it has to be perpendicular to the base, and the slope of the base here is -3. So the opposite reciprocal of -3 is 1/3. So if I make a line with a slope of 1/3, it should be perpendicular. So if I go up 1 over 3, there'll be a point right there. That line will be perpendicular. So we can see on this acute triangle that the orthocenter is inside the triangle. For the obtuse triangle, one of the altitudes is right here. That's perpendicular to that vertex. From this vertex to this base, if we do a perpendicular line, the slope of this line is -3/4. So the opposite reciprocal would be 4/3. So if I want to go from this point with a slope of 4/3, go up 4 over 3, would have to go through that point there. And we can already see that oops, I need to move that line over just a little bit and go through the vertex there. There, now it goes through the vertex. And we can see that where those meet is outside, so the orthocenter of an obtuse triangle is outside. And for a right triangles are really handy. The altitudes are the legs, so the altitude to this vertex is that leg. The altitude to this vertex is that leg, so we can see right there is going to be the orthocenter. On a right triangle, the orthocenter is at the vertex. To find the orthocenter, you just need to draw a segment that's perpendicular from each vertex to the side opposite. And to start here, E is the easy one. We can just draw a straight line down. And that would be perpendicular there. Okay, to find the other ones, we need to know the slopes of the line. If we want to do the line through F that's perpendicular to ED, we need to know the slope of ED. And so I'm going to put a point there, and we'll see that the slope is 4 over 1, or 4, slope of ED. So the opposite reciprocal of that is -1/4. So from F, I'm going to use my slope of -1/4 to find that perpendicular line. And that would be right through here. And that should be enough. We know that all the altitudes will meet at one point called the orthocenter. So there's that point right there. And that point is 5. 5 up. That'd be -1. All right, you can go ahead and try that. Just to show you that the other altitude will meet there also. If we draw a line perpendicular to this line, that slope is -4/3. The opposite reciprocal would be 3/4. If I draw a line from here and I have a slope of 3/4, that line goes there, and notice it also meets at that point. Concept summary. The in-center is created by point of concurrency of the angle bisectors. And we can see that because those angles are the same on each of the parts. The orthocenter, you will notice, is at the point of concurrency of the altitudes. The centroid, you'll notice, is at the point of concurrency of the medians. And the circumcenter is at the point of concurrency of the perpendicular bisectors. All right, we'll check our learning here. And that's a wrap. See you tomorrow.